Okay, today we're gonna be doing our network diagrams, right? Let me put a pointer, a laser pointer. Okay, today we're gonna be doing our network diagrams, right? This is what a network diagram looks like, right? Like this, right? It has connections, and the connections connect our task patterns. So what is a network diagram? Is the connection of different tasks using task patterns. So these are different tasks. The user requires investigation, existing system review are different what task using what task patterns. So we're using dependent, multiple successor, and a predecessor, right? Patterns. So I will explain the task patterns on the following slide, right? So the duration will be in days, right? What does this mean? It means that this represented 1 days, 40 days, 20 days, right? Okay, now you know what how a network diagram looks like, right? So let's explain what is our task patterns. Task patterns. Tasks in the work breakdown structure are arranged in a logical sequence called task patterns. Remember, a network diagram represents the task which you have identified and named on your work breakdown structure, right? So there are 3 types of task patterns. The first one is dependent task, the second one is multiple successor task, the third one is multiple predecessor task, right? It's very important for you to know the difference of these 3 task patterns. I'll explain them further. Don't worry. How do we write a task? How do we write a network diagram? In order for us to write a network diagram, we use our task boxes to create a network diagram. It's very important. We use what? Task boxes to create a network diagram. A task box contains important information, right? It contains the task name on the bar on top, the start day or time, the end day or time, the task ID, which like a number, we can say ID1, ID2 to identify the task, the task duration, with how long the task will be done, right? For how long the task will be done. Figure 1. Each section of the task box contains important information about the task, including the task name here, task ID here, task start day here, task end day here, the task duration here. Right. Now, as I said, there are 3 types, right? So the first one is dependent task. Tasks that need to be completed in a sequence, in an order, like from A to B, from top to bottom, a sequence, right? Task 1 can be initiated only after the priority task has been completed, right? One task can be initiated only after the priority task has been completed. What does this mean? This one, the investigation, is what? Is a priority task. Now, it can only be initiated once the user request task has been completed, right? It will start on day 1 and end on day 10, right? As you can see that this one will start on day 11 after task 1 has been completed. That's when task 2 will start, right? That's very important to remember. It can only be initiated after the priority task has been completed, after the first task has been completed. It's very important to remember that. Figure 2, this example of dependent task shows that the finish time of task 1, this one, day 10, it will be finished on day 10, controls the start date of task 2, this task, which is day 11. It will start on day 11 after this one has been completed. It was completed on day 10, then it will start on day 11. They happen sequentially, one after the other. Multiple successor task. First, let me explain the word successor. A successor is something which comes after, right? Successor task comes after. Now, tasks that can be initiated at the same time. Multiple successor tasks are tasks which can be initiated at the same time, can be started at the same time. Tasks are termed parallel. They happened parallel or concurrently, right? Often two or more parallel tasks depend on the predecessor task. What is a predecessor task? A predecessor task is a task which happens before, like this one, existing system review, happens before. The existing system review happens before the detailed design and before the implementation, right? But the detailed design and implementation are what are successors. They happened when? After. Right. Now, these two tasks, they happen concurrently. They start at the same time. They happened parallelly. Right. They start at the same time. Let me prove it to you that they start at the same time. Start day is 41. Start day is 41. You see? The start day is what? 41. The start day is 41. And on day 40, they start immediately after. On day 41, on day 41. Right? They happened when? Concurrently. Multiple successors. These two. Multiple successors. They happen immediately after the existing system review is done on day 40. Then on day 41, the two of them start on day 41, day 41. Therefore, we call them what? Multiple successor task. Figure 3. This example of multiple successor task shows that the finish time of task 3, this one, task 3, determines the start time of task 5 and 3. You see, it finished on day 40. Then these two, they start on day 41. Day 41. They start at the same time. They happen parallelly. Right. Let's go to the next task pattern. Multiple predecessor task. As I explained before, that a predecessor is something which happens before. Right. So, multiple predecessor tasks, these two, they happened, the detailed design and implementation happened before the review. Is that clear? When the initiation of a task depend on the completion of two or more tasks or two or more priority tasks. So a multiple predecessor task is when the initiation of a task depend on the completion of two or more priority tasks. So review task depends on the completion of these two tasks. You see, that's why we call them what? Multiple predecessor task, because the review depends on the completion of two tasks, which are detailed design and implementation design. So they both start at the same time, day 41, day 41. But this one started day 66. Right? But this one ended day 60. This one ended day 65. Let me explain this. See, how do you determine the start date of a what? How do you determine the start date of the preview task? Right. In order for you to determine the start date of a preview type, you look at the one which is having the largest finishing time or duration. So between the two predecessor tasks, these two, which one has the largest finishing time or the largest duration? This one has 20, this one has 25. So which one has the largest one? Implementation has the what? The largest finishing time or duration, which is 25, right? So this one, the one with the largest duration, controls the start time of what? Of a successor task, which is what? The review task, right? So this one will end on day 65. Therefore, this one will begin on day 66. I hope we are clear there. Now, let me read this example for you. Figure 3. This example of multiple predecessor tasks shows that the start time for the successor task must be the largest finish time for any of its preceding task. You see, the start time for the successor task must be the largest finishing time for any of its preceding task. So we found out that the largest time or largest finishing time was the one of what? The implementation task, which was 25. So it will control the start time of what? Of the preceding task. Task 5 ends on day 60, while task 6 ends on day 65. So task 6, this one, controls the start time of task 8. The start time of task 8, right? The IT, we call it 8, so we're gonna say it is task 8. That's I did explain what an IT is, right? So now it controls what? The start time of task 8. So the one with the largest finishing time of the what? Of the preceding task of this one controls the starting time of the successor. It's very important to remember that the largest one or the largest finishing time or the largest duration will control the start time of what? Of the successor task. Since this one has 25 days, this one has 40 days, is 20 days. Therefore, the largest one is 25. So it will control the start time of what? Of the successor task, the one which comes after. Therefore, this one ended on day 65. This one started on day 66. It's very important to remember that all the time. Make sure that your calculations are correct. Calculating the critical path. Critical path. What is a critical path? A series of tasks which, if delayed, will affect the completion date of the overall project. A series of tasks, if delayed, if one is left behind or it takes time to complete, because each and everything I need to estimate time that it must be done in 20 days. If it happens that any task within the series of tasks which you have chosen to be your critical path is delayed, then it will delay the overall project, right? If any task on the critical path falls behind schedule, the entire project will be delayed. The entire project is what? Is delayed. If one task within the critical path which you have chosen falls behind, the entire project will be delayed. Calculating the critical path. Review patterns. You have to review your patterns, right? Determine the start and finish dates. As I explained there, that a network diagram is made up of what? Of task box, right? The task box has important information, which will be the item name, the start day, the finishing day, the duration, and the ID. Therefore, you have to make sure that you determine the start and finishing dates. Determine a task which has slack time within your your network diagram. You have to determine a task which has slack time. What is slack time? Let me explain. The amount of time a task could be late without pushing back the completion date of the entire project. In order for me to explain that, I will have to go back to my space slide. Let's go back here. Right. Let me first explain what are paths. Okay. Path number 1. Let me change this. Let me put a pen. There we go. Path 1. Path 1. Right. This is path number 1. Path number 1 would be 1 here. Would be 1, 2 here, 3, 5 and 8. That's path number 1. Starting from here to here to here to here to here. That's path number 1. Then path number 2 will start here. Path 2. No need for me to write path. Let me write it. Path 2. We'll start with 1, 2, 3, 6 and 8. It will start here. Path number 2. 1, 2, 3, 6 and 8. That's path number 2. Therefore, it's obvious. What is path number 3? Path number 3 will start at 1 here, 2, 4, 7, 8. That will be path number 3. So what does that mean? It means that our network diagram has how many paths? 3 paths. The first path would be from here to there. The second path here to there. The third path here to there. It has what? 3 paths. Okay. Now let me explain the slack time right here. The slack time. Okay. Slack time. Okay. We're gonna look at these 2 tasks. Existing system, new system request, right? They both start at what time? They both start at day 21. Day 21. Right. But this one end on day 40. This one end on day 50. Right. What does that mean? This one ended day 40, this one ended day 50. This one takes long to end, which will end on 30 days, right? This one ends sooner than this one, in 20 days, which means this one end in less than in less than 10 days, right? This one. Therefore, this one has a slack time. This one has a slack time of what? Of 10 days. Therefore, it can be delayed. It can be delayed for 10 days. It can be delayed for what? For 10 days. But this one, but the system request doesn't have a slack time because it cannot be delayed with any time. It must be done within 30 days. I think I hope you understand, right? This one doesn't have a slack time. This one, the existing system has a slack time because it will be done within 20 days. This one will be done within 30 days. So it has extra 10 days compared to new system requirements. So this one will be done in 20 days, this one will be done in 30 days. Therefore, this one has more time, which will be what? 10 days. So this one you can manage to delay it. It can be completed in day 21 or day 20 something, right? But it cannot be delayed for more than 10 days. So its slack time is 10 days. Therefore, it can, even if you delay it, it doesn't change the overall completion of your project. So it has a slack time of 10 days, right? I hope you understand me there. So in order for you to determine your critical path, you must choose items or tasks within your critical path which do not have a slack time. In order for you to determine a critical path, you have to choose items which do not have a slack time, or if you are working with many tasks, therefore each task has a slack time, like this path. This one has a slack time, right? And this one has a slack time. Slack time here, slack time here. So you just have to find the difference of your slack time. Let me go, where am I? Here, right? Determine a task which has slack time, right? Remember what a critical path is: a series of tasks which, if delayed, will affect the completion date of the project. So you have to, a critical path must be the one which has a less slack time or has no slack time. I hope you understand that. Thank you for watching the video.